This is Team Cardia, and I'm Garrett Morgan, the team lead.
I am Anush Adhikari, the hardware lead.
I'm Jorge Galeana. I'm the software lead.
And I'm Sriyan Singh. I'm the team reporter.
Our project, so it's water monitoring system for automated inland shrimp production. And what we do is our project is an automated system that monitors water parameters for shrimp productions. Parameters for water such as pH, oxygen, temperature, feed, salinity, turbidity, and ammonia. This way, we can reduce import cost as well as the shrimp cost by cultivating them inland. All the parameters are collected and sent to the cloud and can be accessed and changed via our cross-platform mobile app. Next.
Okay, so why did we do this project? Why did we feel that we should be doing this project is because right now, as you can see in the graph, our reliance on shrimp on foreign countries is really high. We do not grow that many shrimps in the U.S. Domestically, so we plan to become more self-sustained in the market because of this system. And since we're domestically growing more shrimp, it's going to be a lot more cheaper, and the shrimps are going to be more fresh. And if you automate this process, it's going to be one more thing that's going to be like future-proof, and it's going to be a scalable thing. Next.
So how do we plan to tackle this issue? ESP microcontrollers, are the Arduino Duo microcontroller, Raspberry Pi compute modules, PyCom GPY, which is what we use to connect our microcontrollers to the internet, various water sensors to monitor everything, various motors to actually change the environmental parameters when they drop below optimal levels, and then a cloud-hosted MQTT service, which is what we use to communicate between our microcontrollers and our mobile app. So you can see a picture of our different controllers, and then a picture of our cross-platform app, which will run on both Android and iOS, and then various sensors that we are using.
Yeah, the skills we learned as a group are networking between different vendors and other people, hosting all of our stuff on a cloud-based system, 3D design and printing of different enclosures and systems for our project, PCB design and printing, and also app development for the system. Next. And these are the acknowledgements for all the people that helped us with our project. And now we'll show you a short video on how our system works as a whole.
All right, this is our working model for our Cardia shrimp system. We'll start with my pH sensor, which is right there, which shows, test the pH, and if it's too high or low, it'll put a solution in the water that changes it to the correct pH so that the shrimp won't die.
For oxygen, which is really important for any aquatic life, there's an air pump that's also hooked up to an oxygen sensor, and as soon as the oxygen drops below a certain level, it turns on and it puts oxygen into the water, and then the shrimp are happy.
Right, so this is going to be the EC sensor, the electrical conductivity sensor. We use it to find the salinity of the water, determine if it's salt water or fresh water, and accordingly we set the rest of the parameters for the better life of the fish.
Okay, so what we have is the temperature sensor at the very bottom. As you can see, it's sticking up. So that measures the temperature of the water, and it sends the value over to the board. And then it's also, at the same time, it's calculating and it's also determining if we need to cool down the water. And whenever we need to cool the water down, the fan is going to be on for the Peltier module, and also the pump is going to be pumping water into the module and putting it out, the cold water into the water. So that's the temperature department. And as we move over here, we have our main controller, and this guy is receiving the data from all the subsystems that you just saw, and it's uploading to the cloud, and then that data can be fetched from the app. Thank you.